Da. Hello all. I think now is the time to start. So please excuse us for this delay, 15 minutes, but you know, the whole Datathon was a challenge and an experiment also for us, as well as you. We have some delays in terms of voting and about the results. But meanwhile, I will show you, for those of you who are offline and for those of you who are online, a little bit more insights about what happens the last 2 days. The last 2 days, which were full of enthusiasm, fun, experiments, and a lot of learning. So I will share what we did virtually. Just give me a second. So for those of you who were physically in Bulgaria, after the opening, which was on Friday, and presenting the mentors, we have a lot of ice-breaking sessions. We have one of them where you can see a lot of people have participated. Also, we have an Impro Pro, and where for a half an hour there were 2 sessions from professionals where we put the data scientists in a not so normal situation, is to be an actors and have fun and present themselves. And it was really funny, and we tried to moderate that and be sure that everyone are happy. And also, what else, you know, the work there. It is the venue which we were in the FEBA. It's Sofia University. It was very good and very comfortable for us. We have more than 4 or 5 rooms, something like details. In terms of volume of beer, we reached more than Marchev. How many was that? A volume of beer? About 100 and something liters. Also, in terms of participants, there were more than 140 participants online and offline. For the offline, there were around 50 or 60 people. So I guess all of you are now here, seeing the results and what are the next steps. Also, we have people from Mexico. We have people from Morocco. We have from US, which is normal, France, Germany, China. So more than 20 countries, and it was really challenging for us because now it was the first time when we are trying to make the Datathon on a virtual platform, to make it a virtual presence and people to be able to use platforms similar to Slack, which is called Data Chat. And now we will receive a feedback how it works. There were initially 39 teams who were formed, and at the end we have like 24 or 25 articles at the end which are published. We are so happy because we see a lot of good results, a lot of details, a lot of data science stuff, a lot of details which we believe that people sharing that knowledge, that experience, that code which they created, this can be the first step where then their mentors, also all of you, can read these articles, learn from them, and provide comments and feedback. Because one of the first Datathon which we did, the problem was that there was no feedback. Because it was physical, someone stand in front of us, present a very splashy and gloomy presentation, and that was all. Now we want with the online give you that chance to learn and develop and see what else you can improve in this domain. All of you know there were 9 cases. The top 2 company cases were SAP and Kaufland. So SAP have like 6. And Kaufland 7 cases. Something what we did, we make 8 groups of different companies of different cases where now the mentors are voting. We are still waiting for one group, one of the mentor. So for the rest, we have the results. Something else is, if you have some questions, we are also very active and on Twitter. There was, yeah, what else we have? Ah, okay, this is my presentation. It's not something interesting, so we have a lot of funny stuff, but it was more like messages. Also, we are monitoring the Datathon 2018, so if some of you online are having questions, please raise them here. What else I can say about the cases? There were cases with the NLP. Also, we have cases with computer vision and image processing. This is the Kaufman case. People really like that case, especially the part with recognizing fruits, different objects within the grocery, and make a recommendation of that. Also, SAP was the case with relatively small data, small amount of data, but yeah, is Agamemnon here? Okay, probably he's voting somewhere. So what was interesting that the cases, the sample was really small. It was 140 lines. The feature were around 9 or 10, but there was the task was here to generate more features in order to be able to make a good recommendation in terms of pricing and promotion for FMCG retailer. The case was interesting, but yeah, some of the people don't really need a big platform like the platform from our partners, Microsoft and IBM. What we noticed that a lot of people decided to use the platform from IBM and Microsoft, but for some of the cases it was not necessary. Now also is the time to mention in our other cases. I will just open the website, just not missing anyone. So we have Receipt Bank with their computer vision case. There was only one team for them. Kaufland with seven or six, correctly if I'm wrong. The next one is Telenor. Telenor, it was a social network analysis. Interesting and challenging case. Also in terms of data, we have some comments because it was a sample of data, but what we saw, the teams did a great job. For the Telelink, here it was not exactly Telelink case, but it was for the DNA case. There are three teams. One of them is from Serbia, so they come here. So hell, yeah, it was. Yeah, they came on Friday night. Also, we have two other teams. One is again from Bulgaria, and another one is international. Then, sorry for the notifications, but yeah. Then we have Identrix. Identrix with 2 cases. OntoText with 3. Also, we want to thank, and ZenCodio was the only one without a case. So this happens. The other one is SAP and VMware. With the VMware, where there are three teams, and that are our cases. In terms of mentors and experts, now they're a little bit busier because they need to provide their feedback, and I think we are almost done. Marchev, how we are? Okay, we need a little bit time. Just now to tell about the agenda and what we expect from now is once we present the top 8 teams, then within 5 to 10 minutes it will be a technical consideration. We need to send them some links in order to start the hangout. So each of these teams will have 3 minutes to present its case, and also 2 for questions. questions which are going to be asked from the mentors. We will monitor the platform data chat with the special group which is exclusive only for the mentors, and we will share. So we will monitor it here, and as I see what's the resolution, I need to read all of them. Then there will be a voting within an hour. So there will be a networking in that time, so you can walk, speak with the others, and then after the jury takes the decision for the finalist, it will be the award and then the party time. So it is as simple as that. If you have any questions from the audience here or within the Twitter, just try to monitor. Any questions? Okay, we have a tweet for us.
Okay, guys, hello from me again. Yes, we have some organizational things, but we're handling them already. We are going to the closer, ever so close to the, pronouncing the finalists. But before that, I would like to say a few words. Being the researcher in the team, I would like to say a few words about the articles that I had a chance to look. Basically, I'm going to say two things here about the articles. First of all, we are really, really impressed. You have done an incredible job in a very short amount of time. All the team, and this is the discussion among the mentors, among the organizers, and personal messages with me all the time. Everybody expresses their amazement of the high quality and the pure volume of labor that has been committed to this Datathon. For which we are very thankful, and by the way, this is the time to applaud all the teams here. So, yeah. Second thing I would like to say. Actually, we had 38 team registrations. Okay, some of them were a sort of double registration, which means that the team merged or they didn't get it right. How are they going, who is going to start the article or whatever. But still, we had probably 3 or 4 teams, cannot be sure, but 3 or 4 teams who actually stepped down. They actually gave up on us, which was a little bit unfortunate. For those teams, and everybody, actually for everybody that's watching online or offline here, I would like to say a few words of encouragement. Yes, it is data science. It has to be exacting. It's not. You cannot be too vague or so on, unless you are using fuzzy methods, right? But at the same time, laboring on some problem, and this is a hard labor, intellectual labor, for 2 days and just giving up at the end doesn't seem, very rational, and we are rational people here. So I'm trying to send the message that you should submit nonetheless whatever you have as a result. You should submit it. And yes, it might not be the best one, and it might not be the best case, and it might not be the winner, but still, it is something that is going to be publicly available, something that you can work on afterwards, and it is something that will have some positive impact on somebody somewhere. So this is why we encourage everyone to publish their articles. And this is why we formed the whole Datathon around publishing articles. This is second thing. I think it's a great moment here that actually our PR team over there dug out the fact that today is the International Women's Science Day or something like this. Women in Science or something like this, which is the International Women's Day for Nerds, basically. So I would like to applaud our women in the audience as well. But speaking on the fact that I wanted you to publish your articles. Actually, we are trying to not only make a competition here. We are trying to, Chris, you're on. Okay, we are trying to make an online and offline community as well. So all of you would have a chance to finish your articles, first of all, if you think there is something to finish, of course. Second of all, we encourage that you tomorrow, okay, after tomorrow, you're sleeping tomorrow, but the day after tomorrow, you get online again and seek another case and solve it, and write an article about it as well, and continue chatting and continue discussing the problem online. This is what we are trying to establish here. This is an ongoing thing. It's not a one-off thing. We are trying to start the train, and it has started. It has been very active for the last week or so. We are trying to move it forward. And as soon as we have confirmation there, we can go on in the...
Yes, something else.
Yeah,
what I can add here is that the data chat, we are not closing it. So you still have access to the mentors. I assume that the company or industry experts will still are going to answer on your questions. So we are not closing it. So if you have any doubts or any suggestion, or if you want to improve your article, go ahead. Read the comments. Also, something which we believe it's going to be very valuable. And this was something, I mean, for those of you who are physically, we try to make it that way, is be supportive and share knowledge and experience. So what we can recommend is to read other articles. And if you see something positive or such kind of advices, share with them and try to know each other. Because now, for these 2 days, you were in one virtual team. You know, all of you, the screen was popping up different messages. So it was like a virtual and offline event, and it was like a new, adventure for each one of us. And something what we... Go ahead. Yeah, now we'll open the final results. Something else for the finalists who are going to be here, you need to tell us, are you going to use our laptop, because we can open the article and you can walk through that. So we will have, for that reason, 5 to 10 minutes to agree this with them. Also, if they're using their own, probably we need to see how it's going to be visualized. You see the resolution is a little bit strange, so we need to consider also that. And
just a second, we are almost ready. And okay, and with this we are moving to our we are moving to our finalist announcement. By the way, guys, we are very economical on music today because we received 10
warnings.
No, it was claims for music rights, copyrights from our last party. But anyway, so without further ado, I'm going to give you the finalists, starting, I don't know, it's some random order? Yeah, okay, it's in random order, okay. Okay, Identrix NLP team, case Identrix, are you here, guys? Okay, somebody is here. No, this is the Identrix.
Let's give them a applause. We don't know, are they here?
No, this is actually I'm seeing the industry expert. I'm asking of the participants if they're here.
Because if they're here, just to be aware of, are they going to present?
So they're our first finalist. Next one is BRGR team, Case Kaufland. Are you here, guys? Are you here? All right. And next finalist is Team Cherry. Team Cherry, I think I saw them here.
Victor, where are you?
In Case Kaufland.
Yeah, he will come.
Next, Team A, OntoText. Next is Chameleons, Case SAP. Are you here, guys? Chameleons.
Yeah.
Next is team. All we knew at the moment when we registered this team is the name of only one author, so we named this team Team Dubrina, but actually their articles is called differently. But anyway, Team Dubrina SAP. Yeah. You should have figured a better name, but this is as good as we have here. By the way, it was a little bit of a logistical problem to find your article for the judges. But anyway, next finalist is 7 Bridges solving the case Telelink iGEM. Oh, so this is not right. Is it Telelink iGEM? Isn't it?
It is
Telenor?
It is Telenor.
Sorry for that. This is Telenor. It's not
So
Telelink.
applause, I think they're here.
Are they here? 7 Bridges, okay. So it's correct, right?
So it's hygiene, okay.
Sorry.
So
everything's fine. Because, you know, bridges, and I thought it was something about social networking and plus, okay, so you're on, guys. And our final finalist is Team Troll from Telenor, for Case Telenor. And guys, by the way, this morning I just misgot the joke. I remember that throw is a joke that's very famous in the AI community. But anyway, so these are our finalists, 8 teams. We are going to have to organize some technical things for their presentations. But from what we are going to do in a few minutes, we will decide how many minutes we need for this. We are going to get everybody on Hangout or in person, give them a chance to present what they want to present. They are going to have exactly 3 minutes for presentation. You should know at least that the presentation is important, but really the most important thing you have already done. This is the paper, the article. Okay, we'll call them a paper from now on. It's high level anyway. So there will be 3 minutes per team. We're going to count the time, and then we're going to give about 2 minutes for questioning. By the mentors, by everyone, or by the mentors only?
It is going to be by the mentors.
Okay.
We will monitor the chat, and if still there is a question from the audience, we can also consider this.
About 2 minutes, not more than that.
Yeah, not more than 2 minutes.
Okay. And after this process passes, we are going to switch. We are going to put our attention to our mentors. They are going to give their final ranking for the 8 teams, and after this is done, we are going to pronounce the winners. But before we pronounce the winners, there will be some gap of time when the mentors need to do their job. And in this gap, we have some special presentation, or maybe not? Yeah,
something what we have from the SAP, Agamemnon mentioned that he wants to present how he solved his case, so within 3 to 5 minutes. So he will just show for those of you who participate and are interested on SAP.
And also the gap, because the jury would need more like not 5 minutes, but more like an hour. In this gap would be a nice time to play some nice music, drink some nice wine, have some nice snack, network around, and anxiously wait for the results. Okay, now how much time do we need?
Yeah, what I will need, please, the teams who are here, within 2 or 3 minutes, come here just to see who are they, because for the rest we need to coordinate this, how we can link the teams, how we can connect with the teams who are online. The best approach is use the data chat. We will try to find most of the members from each team, or at least who submitted the article. We will contact him and send the link, because the link is going to be only as a presenter, so there will be like less than 9, because for the rest it will be streamed. So for online, stay online and be in data chat. We will contact you in the next 10 to 15 minutes.
Okay, so like 10 minutes break?
Yeah.
10 minutes technical break then. Congratulations to the finalists, by the way.
Please, sorry, I could hear myself, so it's distracting me. Thank you. Okay, so the document ID pairs with the keywords that are given in entities to the documents that are in document CSV. And so here are some of the features that are presented in the CSV file. And so when observing the data, we see that we have very noisy data. And so we wanted to restructure this data so that we can actually use it for further analysis. And in doing so, we need to import certain modules listed here. And then I wrote a script to retrieve the data from a file path. And then here are some long code to pre-process the data so that the data is presentable and easy to use. So here, allow me to illustrate here. So I'm going to import the dependencies, get the data function, and then all these two scripts. And then we can preview the data. So in this case, I use document 68. So this will show what the corpus of this document will be, and then the corresponding entities from the entities CSV files. So if we want to do a different example, we can just look at like document 8, for example. File retrieve document 8, entities will be the corresponding entities in this document. All right, so this script here runs to record the results from these two dictionaries into a new CSV file. And now comes the fun part with data modeling. And so in our analysis, we decided to look into trying to pinpoint what the code references of the passages are. And so what code references are basically keywords that indirectly links to the noun that it refers to. So for example, when I say Alice ties her shoe, the keywords that I'm looking for is trying to link the word Alice to her. And so in the process of pinpointing these code references, we wanted to use the neural coreref package, which is specified here. So I'm going to import this module. And then specify a new, start a new server. This takes a while, but. And then once this is successfully loaded, I will implement this code. I can discuss a little bit more about the algorithm that is being used here. So the key idea here is a fairly complex algorithm it's used, so we start off by extracting, so we look at the corpus and we extract the series of mentions that are present in the data. And then for those mentions, we also look at pairs of mentions because some of those pairs of mentions might be associated with each other's. How we were able to do this, well, how the model was able to do this was to assign each word with a vector and allow the model to self-train through some unsupervised learning technique. Principal components analysis being one of them to reduce the number of features that are present. And then using those vectors, we can assign integer representations of all the features that also incorporates additional characteristics such as the length of the word, the words surrounding the word, the mention that we're interested in looking, and the location of the word with respect to the entire corpus. And so once those integer values are assigned to represent those features, we feed it into two neural networks. The neural networks, one of them will be providing a score that is currently state-of-the-art. It will look at the pair of mentions, so feed into the integer values, assign weights onto some of the nodes, and result a score that represents how likely two words are relevant, or how likely two words are related to each other. And so when you run this code, you will get, you can see that the server is running here. So starting to look at all the pairs of sentences. Oh, okay, yeah. And then once this is processed, we see that the results of the co-references are the tuples that are listed here. In this case, those are is referred to as he in the sentence. The list of administrators is referred to as there, and so on. So that's our findings so far, and I'm happy to accept any questions right now.
Okay. Okay, so sorry, I will mute. Thank you. Now we will write the comments and unmute my microphone. So please read the questions into the Hangout. So I'm switching off my microphone. So. So about questions? Yeah, okay, so we are still... We don't have any questions yet. So any of the audience here, any questions about the identrix? Probably the mentors, you know their work best. So Diane, any questions from your side about the identrix case? Okay, let's see on Twitter. Probably. Okay, nothing here. Just see. So use the hashtag Datathon 2018 for questions. And nothing. Okay. So yeah, we don't. I guess we don't have any questions. So.
Okay, in this case, we would like to thank the team, Identix NLP team, and big applause for them.
Yeah.
Good job.
Thank you.
Okay, then we're going to probably switch to the next team.
Yeah, the next team, which is...
Before that, we have to switch the internet here. If there is a better...
okay. So just a second. I will switch on. If you can make an introduction for the case,
Okay,
because apart from the participant, there are... yeah, for the Kaufman case.
Okay, next. The next team to present would be BRGR. You just would wonder if it's two Greek guys and one Brazilian guy in this team. The case that they solved is the Kaufman case, which of course is computer vision case. By the way, I'm giving a few words for those of you who do not know what the case was about. It was about how to automate, to make a little bit more automation on self-shopping, basically recognizing fruits and vegetables and self-checking out. And we have had many and plenty of interesting solutions. One of the most solved case, so I think it was 7 teams with this competed in this case. So I'm going to give the word to BRGR team. I think the name of the participant is, well, her name here is Mada, but I think it's Madeleine or something like this. So this is it, and they have their time.
Hello.
Hello.
For me to share the screen.
Hello, so you can start.
But the screen sharing disappeared.
So you...
The screen sharing option disappeared.
So use here this screen share on the... Okay, so can you find it here, the screen share on the... I can share my screen just to be sure that you can find it.
Okay.
Okay.
Can you see it now?
Yeah, we can, so you can start.
Okay, so hello from Belgium. We are Gerberger team, Madalina and Stefan. And we would like to present you our deep learning approach for solving the Kaufland product recognition problem. Our approach was based on transfer learning, and we investigated a number of different types of network architectures, such as Inception, VGG 19, ResNet 50. I will provide a detailed comparison later on in the talk. First approaches was also to try and train a network from scratch. We were looking at capsule networks and also deep convolutional networks, but due to the time constraints, we abandoned this approach. I will start now with presenting our data visualization conclusions. Very quickly, we noticed that the data set is very disbalanced. We have overrepresented categories such as red peppers, bananas, and tomatoes on one hand. And at the other extreme, we have categories barely present, like the yellow plums. Then there are a series of image anomalies which become a challenge to any training model. For instance, many images contain shadows, and this makes the contour recognition more difficult. Many images also have the presence of human hands, which can again be misclassified. We have some empty pictures or pictures in which the object is hidden by the plastic bag. Then we have a lot of very close categories. For instance, the bananas, which are also overrepresented, and plantains, very much alike. In the same category, we have normal apples and apples. Same problem we have with tomatoes. We have tomatoes panicles and tomatoes meat. We also tried to perform image edge detection and background removal, but as you can see, due to the plastic bag, we didn't obtain very good results. We also attempted to do image segmentation, but we had the same difficulties. However, to improve the performance of the model, we did dataset augmentation by flipping the images. I'm not going to present all the models in detail. You have all the code in our netbook. To focus on the results that we obtained. So we have a nice comparative analysis. We tried 6 different architectures with different combinations of either using the networks as they are with no or training a series of layers and adding at the end either a sigmoid or a softmax. Were obtained with VGG19 and a combination of sigmoid as a final layer. And we obtain an accuracy of 84%, but is for top 1. When we expand this to using top 3, our predictions get to a score of 97.35. So as you can see, this is our score. This one was analyzed on a holdout of 20%. Also spent some time creating nice graphics where we show the confusion matrix. And then we also annotated it with the results that were misclassified. And as we can see that bananas were very often confused with plantains, tomatoes with red peppers, the apples with pink lady apples. We ran also our model on the test dataset, and we obtained very similar results as the ones that we obtained on the holdout. Something else to mention is the fact that due to time constraints, we didn't leave the models train very long. So I think by having a more generous time, we can obtain even better performance. Do you want to add something?
No, just have questions?
So just a second. Now I will just open the question session from the mentors. So probably the section with the questions. We can ask the mentors if they can give their questions in advance or just...
Actually, because I see we have missed a question from Preslav. Preslav, you can ask this question under their article. They can still answer it there. So even if you didn't have a chance to ask it here, you can still ask your question there.
Okay, so here, is there someone from Kaufland with questions?
Okay. Or somebody else?
Yeah, or someone else with computer, Chereshka probably. if you have questions, because you work on the same case.
Okay, well, yeah, I think that we are going to wait like 15 more seconds.
Yeah, Liat is typing.
Liat is typing, so we are going to wait for him.
There is a delay of the online, so there's like 20 or 30 seconds delay, which we didn't consider. So that's why the mentor are typing a little bit slower than what is the lifetime. So, okay, so.
So the question from Miroslav, one of our team members, is about the processing time. Can you give us a little bit of information about that, in particular per image, and in general how long it took you to create the model?
So I will repeat the question. Can you give us more information about the processing time and how much it takes per picture or overall?
Percent of the whole data set, and the training time on our slower machine, it took about 2 hours for one epoch. So we restricted ourselves because we wanted to test several models to basically 1 or at most 2 epochs per session.
So
does that answer the question?
Yeah. So what was per image?
Oh, per image.
Predicted time per image.
One tiny second.
Okay, there is another question from the mentors. Why do you think the best architecture worked for this case? Yeah.
It's five seconds per 5 pictures per second.
Okay, so for the first question, the average speed was 5 images per second on our machine. Concerning the data augmentation, I already mentioned that we did image flips in order to images, and helped a lot our accuracy results.
We have learned about different models which was preferred on.
Preference for several models. To be honest, GGG9 was the best one. All the substance.
Yeah, I guess the question.
We are not.
There are some questions. Can you see in the message, or if you can't, the best?
Yes, the question. Why do you think that this architecture works in this case? And so the answer is, we're only retraining a subset of the networks and not. BGG19 has less layers than the other ones and is a bit faster to train. As far as why it should train better in this particular set compared to the other ones, we have on ImageNet other results. I frankly have no idea. That's the reason we train on all these different ones, because seeing that some certain networks were best on certain data set, but being able to predict which ones are going to be able to perform better ahead of time is very difficult. Hence the shotgun approach with different models and activation layers at the end. For the data augmentation, we did flip the images, at least in part, to establish the principle. Skewing the images, we didn't. There's a slide bias, perspective-induced bias in the images that we get from the in the data set, but we didn't feel that correcting them was necessary considering that they were all aligned in the same direction at the end of the day. The camera angle was constant throughout the images. For the other question, which was, what have we learned about the different models is, well, all of them seem to kind of work, and it's a matter of fine-tuning and maybe training. In this case, BG19 was faster to retrain, a better result with it. I'm not sure.
Okay. So please follow the streaming. We will continue with the offline. So all the other presentations are going to be live on the link on the YouTube.
And big applause to the team again.
Yeah.
I would like to encourage the mentors, actually everyone, to write questions, remarks, whatever, comments. If you have questions towards the teams, ask them under their article, and the team participants, please follow your article, and whatever question there is from the mentors or from everybody else, please do answer.
Okay, so we are stopping the sharing from here in the Hangout, so we are continuing, and you can see all the presentation via the live YouTube channel. Thank you again for both teams. Okay. So now team Cherry.
Team Cherry. Okay. Team Cherry. They have solved the same case.
Just a second. Are you going to use
your
laptop?
Just a second, Victor. Are you using your laptop? Okay, so you're leaving it for the last one. Okay, so no Team Cherry now. Yeah, Team A who solved the OntoText case, please come forward. You're going to use this laptop, right?
Ok. Само трябва да помогнем така да намерим презентацията. Чакай само да излезе.
So, just for some information about the case, OntoText have presented, let's say, I'll call it again, typical OntoText case. It was natural language processing, and it was about extracting context out of free-word text. Huh? Specific relations, of course. This is context.
Okay.
And you're не мога да се отвори? Да, това е. Окей.
Това ти е... Чакай, как да...
Микрофон.
Да, този микрофон.
Окей. В смисъл е така може да си обърна, не?
Да. Само да го... Така мисля, че окей. Искаш тук, искаш това?
I want to actually use it. Hello everybody. Just a minute to find the picture I want to show you. Yeah? Do you hear this? Okay. My presentation will be different from the one before. In 3 minutes, I cannot explain the whole paper we wrote. I will try to explain what we did and why we did it in just briefly. And I think everybody who wants to know more about the case can just read about our paper. So let's begin. Actually, we formed the team just before the competition starts, and it was really exciting for us. Our intent for the paper was not to create state-of-the-art models, but actually to explore the all baseline models and all possibilities of this problem in order to make a breakthrough. I mean, we could easily, well, implement one or two papers from scientists, but actually we won't contribute much because those papers are hard to grasp, and actually if you're just beginning in your path in machine learning, you would need something simpler and something that you can easily, well, feel that it would work. So we actually, well, prepared few tasks for each of our members here, and Vicky, who is from Brussels, and he's the guy who implemented the neural network that is really big and yeah, fancy. We here just tried different approaches, just simpler approaches, and we tried to extract as much information from the data set as we can, and we think about more possibilities, how to create a bigger data set and better data. Anyway, I would also like to add that our approach of the paper was more like just start with something simple and try to expand it, like breadth first search, and find other good approaches to the same problem, rather than doing well, more depth and more complex model. So yeah, actually those 40 hours were rather well, really tiring. We thought we can implement more things and we can try many new well, ideas, but the time passed and we just wrote them down the paper in order for somebody else to try them, because, well, that's actually what the meaning of this competition is. It's not actually to be the first, but to share knowledge and create something well, that will last and will be used by the others. So I think the time's up.
Yeah, so thank you
yeah.
all. So now let's see the questions. Yeah, good.
Yeah, okay. I can answer actually all the questions except those from the fancy network with 2 attentions. Those questions for this network should be, well, through the web chat, because Vicky is listening there and will help you.
So the question is, yeah, you can read it. And
yeah, the question is, writing in advance, what would be the next steps you would take in order to improve your model? Well, actually, personally, I would try to create more data and see if creating more data improves the score. If it improves, it actually will provide us with possibilities to fine-tune better parameters and actually improve the score. Well, another approach is to think about different models at all. I mean, we used some basic machine learning algorithms that are useful for text classification and some neural networks that are, well, really common in text classification, but there are approaches that are more or less mixed of them. We can create stackings, and having more data can improve the, well, the diversity of the models.
Okay.
Yeah.
There's another one.
Well,
No, he's writing right now. Any questions from the mentors, from the industry experts?
yeah, feel free.
Can you repeat the question just for the online?
Yeah. The question was if what was our intent to generate more training examples by using the spin text. Actually, the member who gave this idea is next to me, and we can just give him the microphone.
Okay, so I read a little bit about affiliate marketing, and I saw that these guys basically are using back translation or natural language generation in order to take a piece of text, given a sentence, paragraph, or an article, change the order, but keep the relationships between the entities. So I thought this could be a good approach, generate more data and get more precision. The problem is that I took part of that process, but I was not so experienced, so calling APIs or trying to set a system with Google Translate took too much time for me. So I found a free tool online, but just to process 1,000 paragraphs, it took more than 2 hours. So for the whole data set, it would have taken us 146 hours. So it's something that we can try in the future, but it's just in its time. We didn't get to test them because we had to append them back to the database, and I was trying to separate everything and work with the 80,000 lines that we had. Thanks.
Okay, there is one last.
Yeah.
So the question is about, can you repeat?
Personally, my model, not Vicky's, has F-score of 77, 8. Or actually it's not 8, it's 9, but, I don't remember just, but it's near 78. I don't know if Vicky's have measured his F-score. Anyway, we've measured the F-score of the classical machine learning approaches, and George did some nice work to fine-tune them and improve them to more like F-score of 50 and 60. So the classical approaches without the context of the long LSTM, gave a good baseline. There is a question here.
Yeah, the last one.
That did you experiment with n-grams? Actually, we didn't have much time to experiment at all with fine-tuning and more, pre-processing because, the time was not enough in order to, whoop through all the possibilities. We, written in the article, but there are ideas about n-grams. One is we can use 2 features, not only one. We can use TF-IDF based on words and n-grams, and we can use chart-based tokenization, and we can merge this and create new features. So there are, many variants and many things we can also try to improve all the scores without creating big neural networks that will be hard to maintain and understand.
Okay, so thank you, and please applause for the team. Okay, so now the next team.
Right.
It's Chameleon, so they were...
Chameleon, SAP. Okay, so your time.
Разкажи малко за това.
Okay. The SAP case was the one with the least amount of data and the most business slash economics type of problem. It was about looking into dependencies into different prices, your price, competitor's price. And it is 147 observations, if I could, but you'll be amazed to see how much how many things have been written about these 147 observations. Not only by you guys, but by everyone who solved the case. So basically, you have the floor.
Hello? Yes, thank you. We are here. We are 3/4 of the Chameleons team. This is Metodi, Stefan, and I'm Radoslav, and our fourth member, Ivan, had to leave earlier today. So he's with us online digitally. So, as Junior already mentioned, the business case involves very little in terms of quantity. However, the complexity is a little bit complicated. What we have is 147 weekly observations of sales volume of a certain retail customer, the sales price of this customer, the sales price of 7 different competing firms, and an indicator of what sort of promotion the client actually has. And our job is to somehow quantify the effects of each individual effect, whether it be price of competitors, the promotion, or something else, and to predict the optimal sales volume. What we did initially was, of course, to look through the data, and the data itself is a bit problematic, mostly because we don't have much information about the competitors' prices. Most of the competitors are only active in several short periods or bursts, and we somehow need to include that into the model. What's more, what we have in terms of raw data is the price with promotions and the volume with promotions. In order to actually model the quantity, we somehow need to isolate a base price and a base volume in a theoretical fictional world where promotions do not exist. And more information about how we achieve that and what happens next, you will receive from Metodi. Thanks.
Thank you. So, as Rado mentioned, the main task actually is to figure out from the pure sales volume data that we have, what is the upsell from a given promotion. An upsell is how much extra product you manage to sell just because you're actually promoting it and discounting the price. As this is a hypothetical number, we don't know, we need to model it. So we model it first by observing a base volume, which would be the volume without any sales or discounting. And just very quickly here, we added a few more graphs just before the presentation. Here we show the red one is the actual sales volume as it was observed by the shop or the chain of shops. And the blue line is our model for the base volume without any promotion. So we base this volume around the average periods before starting the promotion with length given by the actual length of the promotion. But certainly this is a modeled number, and we can think of other models to apply here as well as a future improvement. As you can see, the large spikes in the data actually are the result of the promotions, and this is actually what we need to model. And this is our variable that will go later on into the models. Now, linked with the base volume is also the price, which is not discounted. Now, this was not part of the data set which was provided, which maybe because the data is not really there as with the base volume, but still, we need to figure out a way to quantify what is the discount from the perceived by the consumer base price. Any promotion is, of course, based around the perceived value of a product against the sticker price of that product in the shop. So we need to figure out a way to do that, and we actually devised two in the paper, and there are probably 3 or 4 somewhere around in the task scopes for calculating a base price. What we settled finally on is this graph here, where the green dots is the price of the product as reported. This includes the discount, and the red line basically is our base price. I perceived fair price for the consumer, and he bases his decisions against the discount between this fair price and the actual sticker price. So these were the two main modifications to the data that we needed to apply. The first one was the base volume, which was our dependent variable. The second one was the discount to the base price, which is this variable here. We actually added a few other variables here, which turn out, some of them, to be meaningful for our model, where we looked at the price change, pure price change of competitors' price, so that we figure out if the user actually compares last week's price to a competitive product, to our product in his decision-making process. We looked at is the product actually in a promotion, which is important, but also we looked at is the product, how long has the product been in promotion so far. And this turned out to be a very slight effect, but still statistically significant effect. And in the article, we call this consumer fatigue from the promotion. So what we believe is happening is that if you are seeing a given product being in a promotion too long, you tend to not buy that product too much, because you already kind of assume that the price is this discounted one, so your decision-making process takes into account how long a given promotion has run. And we have also some other variables, but ultimately we settled on a model, a linear regression model, where we have the upsell on one side and the price effect, the variables I just mentioned. We run this through OS regression, and finally we did a little bit of a feature selection in a stepwise based around the IKK information criteria, but ultimately the time ran out to try certain other things. That said, the in-sample adjusted R-square is almost 74%, so it's workable. It may not be the best, but it's still workable. Okay. And yeah.
Thank you.
And now let's see the questions. Or for those of you who are having questions here, please go to the microphone because of the online. So over there, and Vicky.
Some of the predictors were not significant, at least I got this idea, component 5 or something like this.
Well, most of them were actually quite significant.
For the sixth one, yeah, comp 6.
You must understand, there are actually 7 competitors, and they change throughout time. So their products are not on sale throughout the whole 3-year period. Some of them are on sale, for example, for 3 months. Thank you. For 3 months in any given year. So the amount of data there is available does not really lead to too much.
No, I understand that when you do model, sometimes stuff like that happens. Yeah. I just wanted to get an explanation of why this particular one is not significant.
Yeah, basically the feature selection was based on the KIK information criteria. So it's a stepwise selection where we look at the whole linear regression as such, not purely on the p-value, which these stars here indicate. So while the individual variable does not have a p-value over the significance, these variables tend to improve the information criteria for the whole regression as a whole.
Understand. Okay.
I think there was. There is a question here on the online chat. Would you consider to have a confidence score on your dependent variables so that the business can run simulation before doing such promotions? One of the things that we really wanted to show, but unfortunately time ran out, was how a what-if or scenario analysis would work within this setting, where we apply a given promotion for future periods in time and see how, based on this model and the results as up to today, would be modeled with a new promotion of a given magnitude. But yes, we would really like to consider something like this in the future and maybe expand the article as such in the coming weeks.
Okay, any other questions? And no, so there is in the chat. But we answer.
Just one more question.
Okay. Sergey. Yeah.
I think one of the objectives of this case was to find the cannibalization effect of other products. Could you please tell a little bit how did you establish this dependence and how?
To be honest, very early on, we were a little bit hesitant to start working on actual cannibalization effect because as we found it online defined, this means that the consumer chooses another product and not your product, or in a given set of different products which are very close to one another, let's say pork and chicken, and you run a promotion on pork, this cannibalizes the sales of chicken. But in order to estimate this cannibalization effect, you need to have the volumes of both pork and chicken. And here in the dataset, we only have the trading volume of one product. So it was a little bit difficult to wrap our heads around where the cannibalization effect can be estimated based only on one product.
We had the same issue, so I was just curious if you find a solution for this.
Okay. We didn't. So the answer is we didn't.
And one question from Agamemnon.
If I can add something.
Yeah, go.
Well, this question is fairly interesting in general because this is something that is done in marketing. In some early versions of our data, we actually found semblances of the reverse effect, a halo effect from the sales of one of the competitors on our own sales volume. We did try to separate only the effects of the prices of other competitors at one point, and for one of these competitors we noticed that our base price, based on that model, was far lower than the, not base price, the base volume was far lower than the actual volume we noticed. So if we had more data and more information about what the goods are, we would be able to quantify a halo effect from the promotions of other competitors on our products. But we were not able to find this in our final draft version in the analysis.
Okay, we have several questions, but let's choose one. I guess from Agamemnon. So the question is, how would you try to increase the accuracy of your model if you had enough time?
Well, certainly, as we began this talk, the two most important variables in this model are actually the actual upsell, which is estimated upon the base volume that we have. So a better model to estimate the base volume will help improve better estimating the upsell, and henceforward this would hopefully improve the accuracy of the model. The same goes with base price. Our model for base price was based around a particular algorithm to encompass and figure out the perceived assumed fair value for the product. Further models are possible, including dynamic linear models to be applied to both the volume and the price, but yeah, this is what we could look at.
Okay, so there are other questions I will ask, yeah, because of the time, just write them below the article and they will answer on them. So again, applause. And now we have the next team, again working on SAP. So please applause them. So it is called Dobrina team?
We called it Dobrina. We didn't have any better way.
So here, okay, there will be a memo and presentation. Let's see, is it working? As everything up to now. I was so close to format it. So. Okay, you can press just a second. Yeah. So, it's your time.
Okay, thank you. So our team also worked on the SAP case. I would like to thank the organizers first and Agamemnon for being so helpful on this case and also the mentors. I will not go into too much detail about what this case was about because we already heard that. I will focus on what we did on this project. As you already know, the main goal here was to look at the price and the promotions effect for a fast consumer moving good. What we did for understanding better the data and actually working on the base price, which was very crucial for this project, we derived our own base price, which took the price in the period before promotion and the price in the period right after the promotion, and we did the linear interpolation between these two values. And of course, when we were on promotion, we used the price on promotions. So you can see on the graph that our base price actually is the highest of all prices on this graph. What we did also to create new features that we were trying to include in the project, we did a smoothing and we tried to remove the promotions effect from the volume of sales. You can see the black line. We also derived a big number of variables. We have about 150 new variables derived for a data set of 146 observations. So most of them were related to the price differences, the difference with the price of our competitors, some dummies, whether we are on promotion, what is the time since the last promotions, what was the highest price on the previous promotions, and others. We also included time series effects doing Fourier analysis. Here we found that the first and second week before our week were the most had the most significant effect, so we included them as new variables that allow for this lag to be included in our model. We also found two important holiday weeks. You can see them on this graph, so we included them also in the model. So here's our model. We have an R-squared of 81%. We have only 10 variables entering this model. They're over here. So of course the base price is a very important feature of the model. Also the discount, the highest discount from previous promotions, volume of sales, which week are we from the starting of promotions, which type is the promotion. There was one specific type, type A, which was really important. We have some variables that allow to look at the cannibalization effect. This is the price difference with competitor number 3. So we found that as closer we are to his price, we lose sales. And we found that if we have only one competitor on the market, this is also good for our sales. This is how our predictions look plotted against the actual value of the volumes. And what we did in the end was look at best and worst case scenarios. Here, instead of just using static best and worst case scenario, we applied some penalization so that in the cases when the prices are low, the variability is lower, and when the prices are higher, the variability of our sales is bigger. So this also shows the cannibalization effect that can be observed when our prices are low and we are closer to the prices of the competitors. Here in the end, we looked at the elasticity. These values that you can see show that, for example, for a 1% change in our base price, it will show 1.6% change in the volumes. Okay, thank you.
So now let's see what are the questions, and okay, it's better to take this out. Yeah, just a second. So here we don't. Agamemnon is typing. Come on, Agamemnon. Greece is far away, so you're here. Okay, meanwhile, I'll check if there is nothing on the YouTube channel. And you see there is a delay, so people will start asking questions within seconds. So, okay. So, okay, we can give. What was the most challenging part of this analysis, and how you came up with this elasticities at the end?
Wants to talk about the elasticities?
I want to come
Sure.
What
was the most
Well, the most challenging part of the analysis was to find the baseline price and the baseline volumes, because this part of the analysis includes a lot of assumptions, and we didn't really have much expertise in this sphere. So we had to try different approaches and define different baseline prices and baseline volumes in order to get our optimal estimate. And for the second question, yes, how you came up with the elasticities at the end? It's a standard approach for calculating the elasticity coefficients in regression analysis. We just multiply the parameter by the mean predictor and divide by the mean dependent variable. And these are called elasticity coefficients. So that's how we calculate them.
It's not just.
Oh, I think that this answers both questions.
Sergey has questions.
You also did a great job, guys, like the previous team and all others. You covered all the points. I'm just curious about there was something like to find which promotions were good and which were bad. Did you manage to find some correlations between that?
Can you repeat that, between the promotions?
Yeah, I think there was some questions like to find which promotions are good and which are bad. There was like A, B, C, D promotions.
Yeah.
Because we also struggled on that.
Yeah, there was a question about the promotional effectiveness, and we found that, the pricing effect of the promotion is most important. So if the discount is high, the promotion will be effective. And we also found that the only non-pricing effect which influences the volumes is the non-pricing effects in promotion A. So promotion B, C, D, E are only, we didn't find any significant evidence for any non-pricing effects there.
Okay, thank you.
There is one question. Having too many variables in your model may impact performance. Do you take any measures to combat the potential slowdown?
Well, our dataset was really small, and we work with weekly data, so this is not really an issue. Yeah.
Okay, and there is one last question.
Yeah. So I heard that you have derived more than 140 variables. So after that, in your final model, what kind of technique and metric did you use to select only 10 variables or something like that? And how many of them were in your initial data set, and how many of them you derived them additionally?
Well, I don't think that any one of them was in the original data set. Yeah. So, but as for the first question, we used two techniques for model selection, Wassel regression, and we also used a gradient boosting algorithm, tree-based gradient boosting algorithm, HRG boost. And for example, for the Wassel algorithm, we first we calibrated the parameter of the Wassel algorithm and then selected all variables which entered the model with non-zero coefficients. And from the HRG boost, we selected the 20 most influential variables. And then that way we defined our shortlist. And when we had this shortlist, we started working on the linear regression, and then we used forward stepwise selection approach and also backwards stepwise selection approach simultaneously. Two of our team members worked on these tasks, one for the forward and the second for the backward selection process. And in the end, both analysts get the same model. So it was very interesting. We didn't expect that.
Okay, thank you.
Okay, thank you for your answers. Whatever else questions you would have, ask them under the...
Yeah.
Good jobs, guys. And now I'm going to clear my sponsors' view back because they were, shadowing my sponsors here. Next team would be Team Throw. I'm going to, if you don't know the jokes, guys. Actually, where is the website? Is it here?
Yeah.
If you don't know the joke, read the full name, search articles, it is T-R...
I can take it if you want.
Okay. Okay. And no, actually, I don't want you to tell jokes. Let's make the guys from the audience find out what the joke is about. Okay. Open. Hopefully it opens. Just a second.
I don't need it that much.
No, you don't need it that much? If you don't need it that much?
It's opened.
Okay. So, go ahead. You have the floor.
Okay, so we are working on SNA. This is a graph. Okay, so we were working on a graph theory problem. We had a big graph that is representing people talking to their phones, and our domain experts told us that there are leaders in that community, in that graph, and those leaders are defined on another graph, which consists of social network communication between. Which contains social network communication between same people. So our task is first to split the graph into two membranes and one core, and second to find clusters within all of them and find the leaders. And here we go. Our data should tell a story. Everybody says that, and this data really told me of probably the best story of my life I've seen from data. And okay, I'm starting to work on the case, and I don't even have a slight idea what is a membrane of a graph. And I do what I know to do best. I look at statistics, and it's there. So really fast, a bit of recursive graph decomposition, and we see that there are two membranes, and they are pretty strange. There is one cluster of people only calling. They've never received a single call on their SIM cards, which is super weird. And on the other hand, there is a cluster of people only receiving calls. No calls, they have never made a call to anybody. And those two groups have no connection between them. This is super strange. And okay, we removed those two and we have the core and we can solve our tasks. But come on guys, we cannot ignore such strange membranes. So we look into those two a bit more and we see a lot of strange things. when you see something like that, you think about what is wrong with this, and there were a few wrong things. The first one was the cores were grouped in clusters, and in those clusters was like, let's say, 100 SIM cards, different SIM cards, calling only to one number, literally like a gateway. So we've seen that in computer networking, but this is a phone call network. So this is strange. We have some assumptions in the article, we can read it, but this was super strange. And the other one, okay, you have receivers, probably hotlines, customer supports, and the first thing you do when you see that, you're looking for fraud. And a lot of fraud patterns were there. You cannot verify if it's a real fraud without extra knowledge, but imagine you have a lot of dirty money, you buy SIM cards, you call your own hotline, and you launder your money. So we found a lot of patterns like this, it's worth seeing. But come on, okay, we have a task to solve. So we take the core, and that's the cool moment. We know supervised learning, we know mathematics, we know that everything could be so amazing, it's so much formulas. So we do it. We define a huge features, pretty complicated, and we start our clustering, and then we try to verify it with our measurements for the clustering, and literally it was the worst ROC curve I've ever seen in my entire life. It was like, we thought at first that it's the other side. We thought, what the fuck is wrong? And it was horrible, so we was not so hyped anymore. And a friend of mine told me, no, I'm gonna fine-tune that. And eventually he did it, but this obviously was not the right way. So what we were doing next, we said, okay, we know a bit other kind of mathematics, we know graph theory, let's use that. We try to find weakly connected components in the graph. And here they are, we have clusters, but we were trying to identify the leaders, and now we have clusters. So we are like, what's going on? What do we need to do now? And we tried to use a lot different simple metrics at first, but they were becoming more and more complicated. And in this moment, we were like, okay, come on, let's not build a Death Star. Let's keep it simple. Let's use something very simple. And another colleague of ours told us, okay, a very simple thing in graph is, which are your unique neighbors? Like, with how many people do you communicate? So we use that metric. And magic, we have 85% accuracy. We found 85% of the leaders in the social network graph in our phone network graph. So in our talks we have like, okay, this is amazing, this is our happy ending, maybe this is the first time that happens, maybe we can make something very big, and we verified the results like 5 times, but still we know that happy end does not happen like that, and we know that data science leads you ways that you want to see. So before we can sell that happy end to you, we would like to have at least 5 more hours to test our results. So yeah, thank you.
Okay, so thank you. And something interesting, they stay almost 2 nights? I don't know.
Yeah, 5 hours, 7 hours of sleep.
And they stay sober?
Yeah.
So they didn't, yeah, they were so beer and, yeah.
You know,
poor you.
It's poor us.
Yeah, I mean, they didn't browse in the article, but there's a lot of visuals and a lot of stuff. So yeah, I spent some time also with them, so they did a good job. Yeah, you can read it. So let's see what kind of questions we have. And we have value. Can you read it, or I just need to make everything a little bit bigger? Yeah.
For closeness between an outside node and group 5, why don't you use connection strength also? Okay, outside node and group 5. Outside node maybe means outside node of group 5.
Yeah, the microphone.
Yeah. If an outside node means an outside node of group 5, we try to use it with with closest path. So that means for every node we've calculated the closest path to the mysterious group 5. And we have a hypothesis that it's normally distributed, which means that most of the edges in the graph are at distance 3, I think it was 3 or 4 to the group 5, but some of them are much closer and some of them are much farther. So we kind of use that closeness based on graph theory experience. I don't know, yeah? Do you think it's starting a new kind of social network? Well, I wouldn't say that now. It's a possible conclusion. It literally shows that the people who are most active in the social networks are also most active in the phone network, and probably because they communicated with a lot of people in the internet, and they communicate with probably the same people with the phones, but this should be verified. So there is a match. Probably there will be more cool things to see, but I couldn't be sure about this question.
Yeah, I have one question, because we spoke. You mentioned that you will try to find for the families.
Mm-hmm. Oh, yeah.
Did you do something and any interesting discoveries around that, or what was your approach?
Yeah, we did. So when you find part of the graph, there is a thing called clicks and called enclans. Simple example out of mathematics. So if I call my mom and she calls my sister, and my sister calls my father, and my father calls my mother, we haven't called, not everybody has called everybody in our family, but the enclan, the rows between us are pretty long, so we can achieve every and each one node in our graph. So if you use that, we can identify a small clusters between 3 and 7, 8 people, which are in those groups, and if we have further information about the structure of the node, we can say, maybe that's a family, check it out. The same for companies. We have an additional, like if there is a tree structure, somebody calls somebody else, and is a directed acyclic graph, then you can safely assume that this structure could be a company. So we don't say we found companies and families, we say those structures can be, we need further information to confirm it. So yeah, we found some, let's say.
Okay, thank you. I think we answered everything here. Do you have any questions from the audience? Any questions? Because I need to clear them out to see my sponsors anyways.
Okay, so thank you.
Thank you.
Thank you.
Okay, now we are going to switch to the more technical part of our presentation, meaning that we have to switch laptops. And I'm going to invite T and Cherry, who are also working on the Kaufman case. But because of the hardware issue, we have to let them at the last. Now it's your time.
Нищо не трябва, може би.
Yes, you are good. You are good, Miroslav. Please unmute, yes. Facebook. All right. Okay. Okay, wait.
So you have the floor.
All right. 1, 2. Hello.
Yeah, applause for them.
Miroslav, say something so that we see if we can hear you. Miroslav, can you say something just so that we verify that we have you? Oh, I need to unmute. Miroslav, can you say something so that we verify that we have you? No, we don't have you. No, not yet. But anyway, so until you figure out, I'll just give the introduction. All right. So we are working on the Kaufland case, which has already been presented to you many times. My name is Victor. I participated last year. This is Hristo, Tsetso, and Miroslav are the other 2 team members, and Miroslav will be joining us in a few seconds over the online connection.
Това сигурно смисъл. Звук? Включва ли си звук?
I think so.
Това да...
Let's try it again. Let's try it again. Oh, I know what's the problem.
Okay.
I think I do. Let's try it again. Maybe it's not headphones, it's speaker out.
Okay, speaker.
Okay. All right. Miroslav, can you try again? Say something. Still not working. All right. What else? Maybe not speaker, but
Line
Dell speaker.
out. Okay.
Dell speaker out.
Probably Dell speaker.
That's right.
Next try.
Next try.
No.
Let's try something. I don't know. Right. So I'll have to present for you, I guess. Maybe wait. If I take it out, say something now. But it's your problem because now it's up to you because now I took this out, so I should be able to hear you through the speakers.
As I told you on Friday, AI is easy, but AV in audio video is hard. It's always like this, you know, all of us are here smart guys. We cannot figure out this.
Yeah, well, maybe it's the HDMI thing. Well, anyway, all right. Okay. Yeah, so, and Miroslav he will comment in text, so I will be able to relate his thoughts as well. I think I'll do that. I think I got it. So, what we did is a fast and accurate classifier. So these were our two criteria to have something that is fast, both in terms of, well, we have 48 hours to create it, so in terms of training time, but more importantly fast in terms of per image classification, because it's going to be deployed on a scale, on an embedded device inside the store, so it has to work swiftly, otherwise the customers aren't going to be satisfied. And the other metric that we had is to do an accurate classification. So we don't want the customers to get confusing suggestions. And at the end of the day, we our best model, which is a model derived by from the VGG model that Miroslav constructed, achieved 99.5% accuracy on the test set, that is, and top 3 accuracy. So in 99, let me rephrase what this means. For the customers of the store that gets the suggestion, out of 100 customers, each one of them would be able to find their fruit or vegetable on the first screen that they get. And out of the one customer of these 100 that don't find the fruit there, they would just click next and they would find it in the next 3. So it's in the category of top 6, we have essentially what is 100% accuracy. And most importantly, the running time for the prediction of a single image is just 6 milliseconds. Okay, granted it's on a Titan X GPU, but we extrapolate that these 6 milliseconds will translate to about 2 images per second on some form of embedded chip or hardware. And now Christo will present to you what we did before we trained the network from scratch.
Hi everyone. So basically, before we get to our best model, we tried 4 different approaches. One of our first ideas was histogram of oriented gradients, which is a feature descriptor that is handcrafted. The feature descriptor doesn't adapt with data, so we quickly abandoned that approach because it just doesn't contain enough information to make successful classification. Another approach that we tried was training CapsOnNet from Hinton's paper released very recently. But as it turned out, there aren't any pre-trained CapsonNet on similar data sets, so we had to train it from scratch, and there wasn't enough time on the Datathon, so we abandoned that approach. And for transfer learning, we tried two different approaches. One was, the first approach was to basically get an existing neural network and train it, and also use the convolutional layers in the training. We tried that with DenseNet. It showed some promising results, but there wasn't enough time for that, and also about the time we found another better approach, which was more lightweight. DenseNet has 7 million parameters, while our final network has just 2 million. Another approach which we tried was VGG16, to use it as a feature extractor. So basically, you take, for example, for a given image, you take the output from the third, fourth, from some layers of VGG, and use them as features for predicting. And also try different image sizes, and although this is not our final model, it gave us an insight in terms of the image size that is the most suitable for our final model. And our final model is actually trained from scratch. It's a pretty standard convolutional neural network.
I have an idea how we might actually get Miroslav back on. Can I try? Let's see if this works. Wait. Okay. Taking out the cover. Maybe this will work now. Miroslav, can you say something, please? Again?
Okay, just
Again?
a second. Yeah, okay.
One more time?
You can speak here.
Yes, Miroslav,
Okay.
you are with us now. Go ahead.
Yeah, so Miroslav will tell you more about the our final model.
Well, thanks guys for the intro.
No,
shortly.
Yeah, it's not gonna work.
Probably know that our team had several beginners, so we decided to approach the some hands-on experience how you should approach the problem, not only from the tutorial where everything works, but just try to deal with the problem, even if you don't have good performance with the transfer learning or these like basic approaches. How to train your own architecture. So as already we had some inputs regarding image size and number of layers we should use. So we just added some experiments with augmentation, and then started adding normalization using first dropout. After that, first batch norm, and after that dropout. So at the end, we decided for a really simple architecture, which is like a VGG-like, just with 4 blocks, each block having only one convolution, with just few kernels. So basically, in total, of course, we then flattened it. This is basic concept. So in total, it had less than 3 million parameters, of which 8% were convolutional parameters, which are the bottleneck for training. So the architecture to that was really, really fast.
Miroslav, yes, I need to interrupt because
it's time limit.
Yes, we reached the time limit.
So let's see questions. Yeah, questions. Would you? Back.
Maybe the other microphone.
Так може чете във форум.
Пробуй.
Okay, we don't have any questions from the mentors in the channel right now.
Okay, any questions? Any questions from the audience? Well, you mentioned the processing time per image.
Yes.
It was something phenomenal, if I can recall.
6 milliseconds.
6 milliseconds, but this is for a little bit advanced hardware, I guess.
On a Titan X. Yes.
One Titan.
Yeah, one.
Okay, so it's not really, really out there, but still it's much faster than the typical virtual machine that they got here, right?
Yeah, and we estimated it was just based on experience from Miroslav that on a normal CPU it would probably take like 2 images per second, something like this.
Okay, so it is about tens of thousands faster, right? Tens of times faster. Okay, another question, and the question is, somebody, I heard it here, not only for your presentation. If you have 90-something% accuracy, and you have small, really small budgets of items, I don't know what types of items were there for in a matter of hundreds or something like this, you cannot still get those small subsets of, I don't know what sort of vegetables were there.
Yeah, not every time. Yeah.
So
you can see that in the confusion matrix.
I'm showing the confusion matrix at the moment at the screen, which is essentially you want all of the numbers to be in the diagonal, which means a correct prediction. It's a top one score. But let me repeat what I said in the beginning. If the customer doesn't get the first 3 fruits at the first iteration, he or she will get them in the second one for sure. And they will get these iterations fast, as the model that we've trained is about 10 megabytes. It's a small model. So it would be able to be deployed on the embedded hardware. This is a take-home message that I want to give to you.
Okay, thank you. Questions from? No questions from the forum. Then thank you for Team Cherry. By the way, this was the first team to form. And now finally we give the floor to the next team. Thank you very much. The floor to Seven Bridges, who came all the way from beautiful city of Belgrade, and they will present their solution. They worked on the case of DNA analysis provided by iGEM, and it is a very challenging case the way I see it. Probably not for them, but anyway. Now let's see. What type of cable do you need?
HDMI.
HDMI as well?
Yeah.
Is it a standard HDMI?
Yes, I would say so.
Are we going to be Apple here?
Unfortunately, yes.
No,
I don't.
The point is that are we going to have problems with video connections? This is what is to be Apple.
Yeah. Oh, okay. I didn't know that I hate Apple all the way. Don't tell them.
Yeah. Okay, go ahead.
They won't hear me. Okay. Hello. Thank you for this. Oh, sorry. Wow, this is tiny. Okay, hi. Thank you for being patient. I'm sorry, you're probably tired. We have a small presentation to keep us spot on regarding the time. I hope you won't be bored. I actually thought that there would be some explanation beforehand, but the case is relatively simple. What if we could quantify the DNA in food and use that to quantify the composition of our food? It is an interesting idea. It's not something that we've seen done before, and it is relatively interesting. The approach here is called metagenomic, so we sequence bacteria in their environment. It's in opposition to the standard approach where you have to cultivate the bacteria. You introduce your own laboratory biases. This has the potential to be more exact, more sensitive, but it has its issue. We'll see that. Also, the proposition is that the DNA is preserved through food processing, which seems to be true in the end, and sequenced digital data is easier to preserve than real food samples or biological samples. This is something that should be taken into account. When analyzing what can be in a sausage, because the sausage is like the main star of this whole event, first we identified that there are valid food products which you can eat, but they are either advertised or they are unadvertised and used as substitutes. Then you have three categories: pests, like animals, relatively complex animals that can get there, human contamination from the works, and microorganisms as carriers of diseases. We identified all of those groups, and since there were 6 genomes offered to us at the page as recommendation, we went to the NCBI and we downloaded more. Examples of these, we downloaded a total of 41 individual sequences that we identified as important in this case for creatures that are undesired in food or simply pathogenic. We also include the 42nd category of all the viruses. They are tiny and they don't create much overhead, even though their contamination is rather sporadic. You possibly don't have somebody with hepatitis A always working at the factory, standardly seeding that. Oh, sorry. This is basically our workflow. We needed to create the indices. We needed to bring together all these sequences that we found and create a singular index. The idea is when you are doing alignment, which is based on Levenstein's distance, for those of you who dabble, it's actually, the problem is if you select only a single sequence, you will have many reads because you are aligning a lot of information on less information. Also, the mapping quality as the metric is actually related to all the other regions present. So if you attempt to convert it into a probability, you need to be relatively certain that all the important sequences are in your index. We applied 3 procedures. 2 of them required our own processing, and the third one, centrifuge, is out-of-the-box solution, which also needed index building and everything. We have automated every step based on only the text IDs and an index Excel table. You can download automatically all the data, create the index, and run the analysis yourself. We also conceived our own way of visualizing this. Since sausage is the star of this, we created something called a sausage and pie plot. This is something that should... the idea is to show the main constituents as the outside sausages, as the outside groups, a variation of the pie plot. Well, you can use the inside to show whatever you think is relevant. In this case, we are showing the 3 groups as in our own consensus sequence, but we are also showing overlaps here. There are, with 3 groups, we can show the multi-mapping alignments between the 2. So in this case, we are presenting that there are significant amount of reads who can be mapped elsewhere without proper processing. We have the results for each particular tool. You will see one sausage plot for each. These are the centrifuge results. This is the out-of-the-box solution. It compares in a relatively fast, succinct manner all the sequences given. If you see that the main constituents of the sausage are indeed cow and sheep, there aren't many unmapped reads, as you can see in black. Pig is a minor constituent here, and the tiny gray dot that you can see is actually all the others. This dot is broken into individual pieces and shown in the pie plot in the middle. So in the pie plot you can see that we found evidence of a horse, a chicken, there is some human DNA inside as well, a rat and a mouse. So this is what the centrifuge says. These are also some quick bar plots that it outputs, which you will see if you run our codes. This is the bar plot and the graphlon output that shows you the structure of the constituents. BWMM is the standard in analysis of human DNA longer sequences. We also use BWA backtrack as an alternative. Here you can see that many reads remain unmapped because this methodology is not completely adjusted to it because of the way that Barrows-Wheeler transform works. But the ratios are approximately the same. You can see that the cow and sheep are still the main constituents. We do have pig inside, but we did detect a few more constituents, although with a very few reads. This is all on the sampled 1001 read that we were given. The horse is there again. Chicken is there. Quite worryingly, there is Taenia solium, which is the pig tapeworm, although only 4 reads, as far as I recall. Human, rat, turkey. Somebody slipped some turkey in your meat sausage. E. coli, the small one, and Shigella. Shigella is also pathogenous bacteria, but there is only one of unclassified regarding the species. BLAST is the third component, which is the heuristics for optimized search. You can use it online if you know it. We also wrap the local server. Cow and sheep are there, pig is there as well. There aren't many unmapped reads here either, so BLAST results do correlate well with the centrifuge results. From the other, we don't detect as much, so the sensitivity could be lower here. We do not have ground truth data, but we have horse, Shigella again, so this is verified in some way, and we do have only one mouse read out of the 14 which were in other. Regarding interpretation, it's difficult to unify between methods because they do have their strengths and weaknesses, and there isn't ground truth data. We purposely avoid to do that. You have to select your own method and see adjust it. Unique and total mappings are something that we processed separately, but it is problematic. Unique mappings are not as frequent as we would like to. BWA does insist on unique mappings, and it uniquely maps only 200 out of 1,000 approximately reads. So this is something that has to be taken into account and maybe quantified. False positives could be a problem. It's worrying to find 4 reads of a tapeworm. The sampling problem, this is sampled from a 25 megabyte file, which has millions of reads. This could be a bias of small sampling. Reads are short, 50 bases each, and there could be DNA damage from the processing by chemical conservants and other material. Quick improvements, we could use RNA data for possible expression. You know that staphylococcal infection could occur when you have thermostable toxin instead of thermolabel. This cannot be quantified from DNA. Longer reads impaired when possible. Machine learning for consensus method if we had ground truth data from an orthogonal method, and we could use more than our 40 genomes. All tools are open source, we insist on that. It's written in CWL for a reproducible analysis report elsewhere. It's a common workflow language. It's using Docker for environment, Rabbix Composer for editing, Rabbix Executor for running, and we offer reference files and analysis.json to all people who wish to collaborate with us. You can run this on the cloud, locally, elsewhere, and I have no way of sharing this right away, so contact us. We will send this without any questions asked. Thank you. Thank you.
Okay, some questions from the chat we have. Yeah, go ahead.
Okay. The first question is, there are 2 questions. The first question is, can this approach become a real product in the world, which one day we can walk with in the supermarket? What are your thoughts?
This is a good question, actually. The sequencing part, the wet lab as we call it, is a bit longer. Right now it is difficult to do it on spot if it could be used for the consumer. So this has a potential to be a tracking technique for sanitary inspection services. There are, if you look at the cutting edge technology, we have seen, for example, tiny PCR machine, tiny thermocyclers that can detect, that can be used as detection of gonorrhea. For example, it's being piloted out there. So if it can do PCR and sequencing like that, maybe this can be seen in the near future. The cost of sequencing is dropping down rapidly, so since you can sequence yourself for like $60 right now at a cheaper vendor, you can possibly sequence your food as well.
Okay, thank you. Any other questions?
Yeah. And the other question? Okay, that's from Liat. He said that you already answered half of it, but I'm going to read it anyway so you can, you know, work on the other half. How would you tackle gene mutations or unknown samples which were not in the gene bank, or even worse, if the sample if the samples in the bank are not accurate?
Okay, excellent question. First of all, we did try to use GeneBank instead of RefSeq. So because GeneBank is not as curated, it has more sequences, substrains, and unvalidated data. But unvalidated is good in this case. We were thinking of doing the variant calling as well, if it could be done, to try and differentiate if those variants do regard plausible data or they just resemble noise. This cannot be done with such a small sample. This was a 1001 read, and we didn't actually run it on the whole sample because we weren't sure if we were supposed to know which was the full sample. to bias our data, but once you look at names of the reads, the full sample is free out there, and we would love to do repeated testing on the full sample. It's still not large, it's in megabytes, and the tools are relatively fast once the indices are built, so this can be done in tens of minutes.
Okay. Any other questions there? No questions?
Chris is typing.
Okay, somebody's typing. In the meantime, do you have any questions from the audience here? Well, one thing is that it's not a question, it's more of a remark. We are trying to put everything, at least link-wise, in our cases. So whatever links you have, you put them in the article, so everybody could access it, as you said.
We'll do that.
Okay,
We'll do that.
No? No. Okay, did he stop typing, or he's still typing? So is this a challenging question, or he just... Okay, so it's a challenging... He cross-references in Google during asking question. Okay. Any other comments, questions? Obviously, this is it seems like a very computation-intense problem, at least for everybody here, it seems like. You tackled it very, economically, I would say.
Thank you, thank you. Yeah. We did struggle with the more computational demanding parts. It took most of our time. It was kind of stressful, but it's...
For everybody here as well, so...
Yeah, I know.
No, we're going to wait. Okay, while we wait, I would like to remind everyone, including the jury who are hopefully watching us right now, they are going to have 30 minutes at the moment we stop our final presentation here. So 30 minutes after we finish here, we are going to have, hopefully we're going to have a final result. Before that, do we have a question or not? Okay, no, go ahead. This is going to be the last question.
I guess it's how much time did it take to analyze the whole sample? How did you find out the 1001 read which was added manually?
How do we... Yes. Excellent.
Okay, hi. So when we were analyzing the data, we realized that this was a subsample of an existing publicly available sample, and we compared the sample size to the complete set and realized that one read was an additional read. It wasn't from the complete set. We did a blast search and we found it was a read most probably from Escherichia coli. So it was a fun fact, so we included it in the article.
Good job.
Thank you. But just let me add, like the read name ID does contain a lot of information that may seem like noise, but sometimes it does contain something useful. It contained the repository of the run at the SRADX session number, so it's relatively easy to track that.
So I guess the guy who asked the question was the guy who wrote the case, I guess. He knew everything about it, but you did a good job. Any other questions? All right, then thank you once more to Seven Bridges. So now leave.
Yes, yes, master.
And now we're going to give, of course, now is the time when the jury would start ranking the teams. Now I'm going to give the word, as we promised, to our guest, Agamemnon from Greece, who is going to briefly show his version, let's say as a mentor, his version of how to solve the SAP case, so how the guys in SAP solve their own case, right? Okay. He has worked on this for 5 years, if I remember right, or on similar cases.
Yeah, my main expertise is on this.
Do you need HDMI? HDMI?
Not on this case.
Oh, of course. Yeah. Do you need HDMI or what?
Yes.
Oh, here. Okay. And hopefully it works out of the box.
Let's see.
Just a second. Yeah, go ahead.
Perfect.
So we have, brief time.
So do I have 3 or 5 minutes, something like this? 5, perfect. So I'm Agamemnon Baltagiannis from the Global Data Science team of SAP. I would like to share some views how we are working as a global data science team for a big organization like SAP. So this is mainly what a data scientist is doing, right? But in SAP we believe that standalone scenarios does not leverage value. What we need is to have not only the data science skills, but a platform in order to solve big problems. Big challenges, both on volume of data and from statistical and mathematical perspective. So we are trying to help an organization run simply, and we are not only focusing on analyzing the data, but we are focusing on access the data, storage the data, working close with the IT, prepare the data for the analysis, create the analysis and the final visualization, and then the most important part for us as a vendor to big enterprises is to process and operate the data in a daily work for big enterprises. Okay, you have yeah.
We spoke about to present the results of the case.
Okay, just the case. Okay.
Yeah, sorry, I mean, because
no,
if
it will be fast.
give you the floor,
it is fast.
We have other
So
sponsors.
the case is to identify the promotional effectiveness, measure the promotional effectiveness, identify the volume uplift drivers, and the cannibalization effect. So we have a lot of factors that influence the volume of sales. Okay, I will try to make it very, very fast. In order to solve this problem, we created an application in which we embed the coefficients and the last part of our analysis. So this is the data set. This is the volume in blue here, and we can see that we have some volume uplifts. Those volume uplifts come from promotions. And we can see that every price reduction, here with green, we have the actual price on weekly level. In every price reduction, we have a volume uplift. So the main goal of this challenge is to analyze and identify the volume uplift drivers, and on the same time, identify the cannibalization effect from the competitors. This is how we represent the results on an application only for this product. And at the end, we created a simulation tool, a what-if simulation tool. Using this tool, someone can simulate different scenarios from promotions and from the price reductions of the competitors. What is important? In this application, we've embedded the coefficients, actually the elasticities of the predictive models. So, if the competitor 1 starts to decrease his price, we can see that the volume, he is stealing volume from our sales. If competitor 3 starts decreasing his price and running promotion, he is stealing more volume from our sales. And now we have with a good accuracy this effect, the cannibalization effect. So yes, he is stealing volume from our sales. The question, the business question is, what can we do in order to balance this loss? We can start decreasing our price. And if we decrease our price, we are gaining back the volume of sales we lost because of the competition. Now, if we want to run promotions, we can decrease our price further and achieve those volume uplifts we saw before. So briefly, that was the challenge. I was very happy that I saw that you solved it using R and Python mainly. We have some other tools in SAP, and I would just very quickly would like to show you our platform. This is the development edition. Here under this schema, we created the table with the initial data set. So this is the initial data set that we shared with you. The first step is to transform the data in order to extract new features, and from this feature engineering, try to increase the accuracy of the model. So if someone runs a multiple linear regression model on the initial data set, he will get 55 R squared. This is very low accuracy. So the main challenge of this case was to extract new features and increase the accuracy step by step and rerun the models. So in order to do this, in our platform, we created this SQL code. Okay, it's too complicated, but what we've done, we transformed the initial data set and we created new columns that calculate the temporary price reduction, the weekly price reduction, so it is 23% in this case, 15% in this case, so we created the percentage of the price reduction on weekly level. And we add this column and some other features as a categorical variable to our model. So now we have more features added to our model, and using this second script, we are calling a procedure which applies the SAP Predictive Analytics linear regression model to our final data set. Using this approach, we achieved 91 accuracy. So that was the final challenge and how we solved this problem. I was very happy that I saw that many of our teams, not only the two semi-finalists, but also and other teams that took this challenge, they managed to increase the accuracy of the models. So, thank you.
Okay, thank you, Agamemnon. So now we have half an hour networking and such kind of stuff. So the jury is voting. So within half an hour.
Okay, finally we're here. It's been tiring 48 hours for you and I don't know, 300 days for us. But anyway, we did it, yay! So we are finally going to our final ceremony, which is going, of course, there are a lot of awards. We are very thankful for our partners for helping us here. And first, we are going to give the floor for a special award given by one of our partners. Well, decided to guys come over, all of you. So Laura from OntoText is going to come.
Hello, everybody. Congratulations to everybody, to all the participants. I would like to give, in the name of OntoText, vouchers for an online training session on designing semantic technology proof of concept. And I would like to give these vouchers to Team A. Amazing guys. They addressed our case so well. We are very happy.
Thank you very much.
Thanks a lot for being here and for being great. Thank you.
Само да се покажете на тебе да дадеш и ще се снимаме. Окей. Чакай, за една снимка.
Yeah. So, make a photo with that. Yeah. Okay, good job. Thank you for that. Thank you for the award, and thank you for your participation here. Obviously, it's a great honor if the originator of the case awards you. Then you must have been doing something right. Now, we are going to go through all of our, quickly we are going to go through all of our other awards, but I would like to say something in advance. After we give the final award, we will ask everyone that's here to come on the stage to make a photo, so don't run away, even if you're not the winner, just stay for a while. Let's make it fun after all. So these are the finals. First of all, we want to appreciate the help, the support, the advice of all of our mentors who are going to get special certificates, and thanks for them. This is the right moment to thank them. Some of them had even written full articles to help out the team, so this is a good job. And all of our mentors are going to get a commemorative certificate for this Datathon. By the way, all of our awards are digital, so we are not going to hand out anything here. Why do we do this? Because we have online audience as well, and probably winners, you know. So this is the mentors. Thank for them. Next award that we wanted to give out is an award for the helpers, the advisors, let's say the lieutenants on the battlefield. These are the guys from the industry experts, the guys from the companies. And we decided to appraise the ones who gave their heart and soul to the cause and gave their best to the community of researchers that gathered for this weekend. Initially, we had set our minds to give just one award of this kind, but it turns out that we hardly can distinguish two teams. So, without further ado, we would like to congratulate for being the best advisors, the best experts and so on, the guys from SAP and the guys from OntoText. Please come over, we would like to make a picture with you. So the guys from OntoText had actually started, all of you, had actually started contributing on Monday and have never stopped. They were the most active and most helpful. Thank you for that. And, you know, our guest from Greece, Agamemnon, had actually written the longest and most insightful feedback under all of the teams that were solving their case, and these are 6 teams, and you did a great job for that. So thank you for being so supportive. So let's take a photo. And yes, we give you.
Yeah, we will send.
We will send you digital certificates to all of you. Вече са на публиката също, че не виждам следващия слайд. Вече са публиката, не? Yes, okay. Okay. Now we're going to our already serious awards. We wanted from the get-go, we wanted to give the mentors the power to vote, but at the same time we know that our community is a community of experts, and we wanted to give them a chance to influence the outcome and the outcome of this Datathon. So we decided to go for an audience award, and we initially thought that we would again just give one. It turns out that we should give 2. This is what voting says. And this award actually gets you, each of the team winners get $300 in vouchers supported by our partners. By our partners. So it's something, you know, it's not that bad. So we have the winners for the audience vote are actually this year are and Identrix. Come over, guys. Throw and Identrix NLP team. I don't know if there is somebody who stayed from Identrix. Okay, come over, Dan. Come over. You're as good as anyone here. He's the industry expert. But anyway, so guys, you have been liked the most by the audience. These are the votes under your articles. Okay, for you as well. So. Now it comes down, this is why everybody is leaving right now, it comes down to the hardest announcement, because whenever I announce it, this is the next two actually, the guys here are going to start shooting, so don't shoot me, it's, you know, we're just giving you the news.
Yeah, but I don't mind to shoot you rather than me.
Okay, okay. I'm fatter. I can get more bullets. Yes. Anyway, so I'm going to announce the next 2 awards are actually the second place in the Datathon and the first place in the Datathon. The second place gets 600 vouchers in the values of $600 supplied by our partners. So without further ado, I'm going to announce the second team. It is Team...
Which one?
Cherry.
Team Cherry.
They have successfully applied data science skills and knowledge, outperformed other global teams and won the Datathon. Okay, they were the second one. Good job, guys. Victor has a habit of showing up on these awards already.
Yes, he get used to.
Okay, thank you. Now it's a good time to play music, by the way. But anyway.
Yeah, I mean, sorry for the music, we were a little bit...
I told you we have 10 infringement claims since Friday for using music in live stream.
From YouTube.
From YouTube, so we're a bit afraid. But anyway, we are going to go to the winner, and I'm going to give the honor of presenting the winner to our head founder and, you know, everything else, Sergey Sergeyev.
Okay, yeah, so thank you. Yeah, I mean, I'm just surprised at having such honor. So for us, it was a great. Yeah, we are closing the event, and it is. We saw a lot of enthusiasm, a lot of fun, a lot of people working, sharing, and it was not so easy for us. Probably you didn't know, but we made a lot of experiments.
Oh, probably they know.
Okay, you suffer at the end, but we tried a lot, and for sure we experiment, and we really see your positive attitude, which helps us a lot to improve it. So it is not easy. Now is the time to see who is the winner.
Before you all leave, don't forget, log in our website. We're going to leave all about the cases, solve other cases as well. See the other guys' articles, see whatever they have found as other material. So please browse, chat. This is the main idea. It should go on. And now.
Yeah, and before I finish, I just want to invite all the volunteers and who help us here. Just want to see them. So Petya, can you come here, Chris? Just without them.
It's not everyone here. Look.
Yeah, most of them. Chris. Tony, Alex, come here. Danny. So without them, this event will not happen. So
this is actually only the night shift. the day shift we already let go.
Efremov, come here.
The highest point.
Yeah, and one of the, Michaela, come here. There's a volunteer. She also helped us. Are we missing someone?
We should be missing someone. Anyway.
Yeah, we're missing. So. Stefan. Yeah, come here. Hey. Yeah, now he decided to play, so he helped us a lot before that with the administration, all the accounts there. But now, for the 2 days, yeah. So first, yeah, let's applaud all of them for making this happen. And now, just want to present the winner. And the winner is, I was really surprised when I saw them. They came a little bit later, but they seem to know what they are doing and why they are there. I see a lot of positivism in them. They were so curious, and they are not from Bulgaria. So please applaud the guys from Serbia. So 7 bridges. So yeah, just all of them, yeah, just, yeah. Yeah.
Congratulations to you.
Yeah, just make a picture with you, so just...
Somebody should go and take pictures now. Just
stay here, just make a picture, and then something which I forget to mention from one of our providers, you will have again voucher for $800. Yeah, you will receive it virtually later on. And let's make a picture, and then all of you will be invited. Just a second. So, yeah.
Okay.
Okay.
Before you leave, we are going to publish, because we have to make this as transparent as possible and as geek as possible. We have all the data of the voting of the jury. We have the ranking. First of all, there is a consensus, which is great. Second of all, it is statistically significant, which is also great. So we are good to go. It is fair judgment. We are going to publish all the results from all voting, so it's as transparent as possible. And if you have wondered, yes, this is the rank correlation method by Maurice Kendall. And with inviting you to come over, I'm going to show our last slide, which is, see you at the next Datathon. And come over.
And come here.
Please come, everybody come over. Please, everyone, get on the stage.
Yes.
Please, come over. Може би оттук да следва.
Or probably.
Or just.
Ovako treba da izgleda. Ja sam ovaj ovdje.
Имаме ли кадърен апарат?
Айде сега така, ръцете горе.
Thank you all. And something...
and yes, the next Datathon is not going to be next year. It's going to be this year. So be ready for that. We're making 2 Datathons a year, so yeah, be ready for the next challenge before the end of the year.
And something else to add, we send you a feedback form probably you have seen what kind of improvement we are doing every time. So it is very valuable for us if you give us a feedback, and that's all. Thank you.
If you're in the feedback, and who wants more beer, we can go. We can arrange it tonight. If you want more beer or to have a closing party after our party, we head back to our battlegrounds in the other building, and we drink more beer. Okay, guys, please, I would like your attention for a while. How many of you would like to come to have beer in the other building again? I mean today, right now.
We have 100 liters more.
We have 100 liters of beer.
So is there someone?
Okay.
Okay, so next time we will make it.
Okay. Разбира се, снима. Това да искаш. Ще се селфинираме ли? Ами,